Hi, everyone, and welcome. I hope you all are doing well. This is your host, Mohan. If you remember, a little while ago, I posted a poll here on LinkedIn asking if you, as a database professional, would be interested in a course focused on SQL development, specifically for DBAs. And the response was incredible, and a huge thank you to all of you who participated. I'm excited to announce that from today onwards, I'm starting this brand new series of SQL development for DBAs. Now, you might be thinking, I am a DBA, I manage the databases, and why do I need to deep dive into the development? So, nowadays, the role of DBA is evolving and it's no longer just about keeping the lights on, right? So today's DBAs are expected to be proactive problem solvers and performance tuning experts as well. And what's at the core of almost every database performance issue is SQL code itself. So now think about it. How often do you face challenges like troubleshooting slow queries, optimizing database performance, or maybe collaborating effectively with the development teams? And if you don't have the knowledge about the SQL development, it these tasks will be very challenging for you, and you will not be a perfect fit for your team. So those are all the aspects I have considered while I created while I was creating this course. So once you complete this course and if you add more self-learning, more practice to it, you can become a performance tuning expert. You can enhance your troubleshooting skills. You can bridge the gap with the developers, and also you can increase your market value. So without any delay, let's move to the day one. So in day one, we are going to understand about the data and the databases. So I will start with very basic, and then we will move to the advanced level. We are going to learn about the SQL development, right? So in first thing to ask is, what is data? So think about it for a second, and you might have the definition of data. So data refers to the raw facts, figures, or symbols that have no meaning on their own, but can be processed to generate information. So whatever raw facts come in your mind, those are called the data. For example, if we talk about London, or if we talk about Mumbai, so if you only talk about those words, and if nobody knows about those cities, then that will be a raw data. It does not have any meaning. Similarly, we have number 85, right? If we only talk about 85, it does not have any meaning. So those raw facts are called the data. You can have structured data that can be in the form of tables, or you can have the unstructured data that can be in the form of files, videos, documents. So that is about the data. Now, how we can process this data to get the information out of it. So data becomes information when it is processed, organized, or given context, making it more meaningful and useful for decision making. In our last slide, we have heard about New York or Mumbai or London. So if we are adding, for example, if we talk about Mumbai, and if we add the context that this is a city in Maharashtra or in India, so now we have added some meaning to it, and the information will be the Mumbai is a city in Mumbai or in Maharashtra or India. Now it has become the information. Similarly, in for we have talked about a data or a number called 85. If we add context that this is our temperature in New Delhi today, so we can say like Delhi's temperature is 85-degree Fahrenheit today. Now it became the information. So if you are adding any context or any meaning to the data, those will be called now that data will be converted into the information where you can use to make any decisions. Now, what is database? So you can say like database is a collection of information, or if we talk about the meaning or you can say like definition of the database, it is an organized collection of data that is stored electronically and can be easily accessed, managed, and updated. Or a database is a structured set of data held in a computer, especially one that is accessed in various ways. So in real life world, if we talk about multiple domains, for example banking, e-commerce, social media, and hospitals, all are using the databases, and they are storing all the information in the database. So if we talk about banking, so all the information about the customer accounts, if there are transactions, those are getting recorded in the banking database. In case of e-commerce, whatever product listings are there, whatever orders you are placing, whatever reviews you are giving, those all are stored in the database of e-commerce websites, right? So this is the database. Now we talk about the types of databases. So we have different types of databases. We have relational databases. So our MS SQL is a relational database management system. So in this relational database, we use tables with rows and columns, and we maintain a relation among these. Those are called the relational databases. We have NoSQL databases as well. Those are very flexible, and they do not use these traditional table or relation. They do not use the relation among those tables. Those are called the NoSQL databases. For example, MongoDB and NoSQL databases. Now we have in-memory databases. So those databases are storing the information in memory itself of a computer. So those are very faster, and it processes the information very quickly. But the disadvantage of this in-memory database that once system is shut down, all the databases data will be gone. Then we have cloud databases that runs on different cloud platforms like AWS, Azure, or GCP. And we have distributed databases. So in case of distributed database, the data is present in different physical locations, or it can be in different systems. But when you access it, it will look like like you are using a normal database, and you are using it as a single logical unit. And now we will talk about the RDBMS. So what is RDBMS? RDBMS stands for Relational Database Management System. You can say it's a software that we use to manage the DBMS, right? So RDBMS is a software that manages relational database, allowing users to create, update, query, and manage data organized into related tables. So in this RDBMS, we store the data in terms of tables, and inside those tables we have rows and columns, and we use SQL for queries, and some people also call it SQL, some call it SQL. Both are correct. So earlier it was created as SQL, SEQUL, but due to some copyright, they have changed the name from SQL to SQL. So both are correct. So example of RDBMS are MySQL, MS SQL, PostgreSQL, or Oracle. Those are all the RDBMS. Now, what are the key components of RDBMS? RDBMS, we have tables. So inside, we store all the information in terms of tables. Inside those tables, we will have rows and columns, and we can have primary key that will uniquely identify any rows, and we have foreign key that will maintain a relation between two tables. Now we have a schema. We have constraints, for example, check constraints or unique constraint. We will have indexes that will make our searches very faster. And we have SQL, structured query language, that is a language which we will use to communicate with the database. Now we will talk about the advantages of the RDBMS, right? So we have in data integrity. So data integrity is about the structure and the rules that ensure that whatever data we have, it is valid, it is accurate. And then we have data security. So data should be secure when it is stored in database or in any database management system. So we get this security in terms of users or logins. We can define the access and authorization of those users. We can avoid the data redundancy by using different normalization processes. Then we have ease of querying. So as I said, we can use SQL language to communicate with database. We have data consistency as an advantage. So consistency is about keeping your data stable and logically correct during and after the transactions. Whatever transaction we are doing, the database should be in the consistent state. Then we have multi-user access and concurrency. So in RDBMS, we can have multiple users. They are accessing or using the same data concurrently. Then we have backup and recovery support. So if your data is corrupted or something happened to data, and if you have already created or configured backup, then you can recover that database till point in time. Then we have scalability. So we can definitely scale our RDBMS to support the large database. So those are all the advantages of the RDBMS. Then we have now real life examples of RDBMS. We have already discussed about the banking system. It stores information about accounts, users, or whatever transactions they are doing. We have e-commerce like Amazon, Flipkart, and airline reservation system and healthcare records. So all of these are real life examples of RDBMS we are using in real life. So this is all about today's session. So it was just a basic information about the data and databases. From the next session onwards, we will move specific about the SQL data development. So I'll see you in the next session. Till then, take care of yourself, and I'll be seeing you in the next session. Thank you.